Uh, First of all, we give thanks to God Almighty because of His goodness and love, so that we are given health to be able to hold this conference. Before I want to tell the presentation, I want to introduce myself. My name is Ruben Cornelius Siagian, the participant who will represent the international conference presentations. As for the scope that we will discuss, especially the field of physics and science, we consist of three people, namely is Mr. Samuel Jolardi Sinaga, me is Ruben Cornelius Siagian, and my friend, Kevin William Andres Siahaan. The title topic for the presentations is Detecting Quantum Topological Phase Transitions through the C functions. Okay, so before to know about the article, so we need to tell about the short story or explain the paper. So I want to be tell you, uh, for in the measurement theory and the mathematical physics, topological quantum field theory, or namely is TKFT, it is short name is the TKFT. It is the quantum critical point or the quantum critical field theory to calculate invariance. So, in the recent years, there have been several attempts to find the efficient observations to determine the TKFT of the quasi-particle properties. So, from the presentations, we propose a different and a very effective way to detect the critical point of the TKFT. So by considering the system functions, we propose the C functions as a novel proof the accurate for detecting the locations of the critical points on the topological quantum. So the C functions use a Kepler's wave semi-metal. The quantum tipping point can display a strong Liftshitz like the anisotropy, in the spatial directions. And uh, global feature of the quantum critically and distinguishes very accurately between two separated zero temperature phases. Considering the C function relationship with enthalpy entropy, can detect quantum penetrations can be applied outside the holographic framework. So it is the short story for explain about my topic for the presentations. It so you see get for the statement effect of the past transitions will provide a modern and elegant and universalist development of physical science system, especially in relations about the theory of the quantum physics. Yeah, you see about the right picture to be so the hydrogen wave functions. It is can be explained about the critical point for the left figure on the quantum critical point. It is you can see that for the center it is the quantum critical point. It is the quantum critical point. So the right is the disordered states. After that, on the left is the ordered states and the classical critical, the purple color. It is the classical critical on the picture. So in the in the topological quantum phase transitions or TKFT, it is especially in the quantum space system. The C functions is the natural candidate for detecting phase transitions. So the effect of the phase transitions will provide a modern and elegant and universalist development. You see that in the topological quantum phase transitions or TKFT area, especially in the quantum space system, this area can display uh, exotic feature such as the fractional statistic and the topological degenerations. It is the pictures for the explains about the fractional statistic and the topological degenerations. It is what is that picture about the explain that for the sample. So you see I want to be eraser that and I want to remove. So the parameter shapers of the sort or the calculates a local quantity that can indicate the locations of the TKFT, and it is the importance and fundamental development in the development of the quantum computing. This parameter serves to sort or calculate a local quantity and can indicate of the locations of TKFT. It is important and fundamental development in development the quantum computing. So you can see that for the figure, it is this new of technology on the modern age. It is the quantum computing. This can be explained about the phase transition or the critical point on the quantum. Okay, it can be upgrades for the system like that. After that, the C functions perfectly located the critical point. Yes, the C functions perfectly located the critical point. Even when the quantum transitions is a topological as well as in the discontinuous and continuous phase transitions. We also saw microscopic details of the system such as the quartic coupling values and the spy-finding transitions in the functions probe. So you can see the two pictures about the quantum critical point. On the x is the stunning parameter and y is the temperature. And from the right pictures, you can see the antiferromagnet and the center is a quantum critical matter and the right way is this happy fermions metal. So the proof of the C function theorem is the very independent on the Lorentz periods. So on the monotonic of the C functions cannot be guaranteed. So if a set of the symmetry cannot be proven. Moreover, when the global rotational symmetry is broken, as happened at the fixed point of the anisotropic Liftshitz, the C functions need to be precisely redefined. You can see that for the picture about the holographic scenario, but I want to be read this statement. The C functions have spaced many appropriate tests. It is proof of the holographic scenario. Therefore, we will use it here and the investigations for GKFG. So I want to tell about the equations for the slide. To understand the basic dynamic of Vs. So what the Vs? Vs is the Weyl semi-metal. Weyl semi-metal. So what the Weyl semi-metal? So, where's a metal is this new 3D material. Whose band structure is characterized by a point singularity, at which speed two bands on the contact produce a linearly spreading cone. The low energy described at these points can display about the relativistic symmetry. So it is for the short statement on the Vs or the Wales semi-metal. So I want to be read that statements to understand the basic of dynamic Ws and TKFT. It is the sufficient to consider a simple weak paired field theory in which the fermionic Lagrangian. So I want to be show to you for the fermionic Lagrangian. It is that yes, it is have the more symbolic for the equations. So I want to be translated for M. It is mass parameter. B is the vector that describes the separations in the momentum space of the two wave cones. A is this potential electromagnetic, and E is this metric directs. Sorry. So most importantly, the axial anomaly represents the anomalous conductivity, and which is not zero. Only in the Weyl semi-metal topology you can see the equations for that. After that, I want to examine the semi-metal Weyl holographic model and demonstrated that the shift functions can serve as the highly efficient tool for diagnosing the equations of TKFT. So the pictures, the purple color, it is a semi-metal Weyl holographic, and it is demonstrated the shift functions to be served a highly efficient tool for the TKFT. Okay, it is introductions for my presenter. After that, I want to tell about the theoretical basically for my paper. My paper theoretical, the first one is this topological passes transitions. Okay. Um, you know, the equations of the holographic model can be determined from the MIME 5-dimensional mass actions. You see that for more of the symbolic for the equations. Instead of the equations being writing in the vector u1 in the fields b mu, and you see the first on the left equations, it is the derivative of the covariance, and it is the potential scalar on the is that v it is and the mu psi ini it is more of the equations if you substitute it about the potential scalar and derivatives of the covariance and the equations. So we use anisotropic in the following directions x3 for the various fields d square. This various fields, and you see the equations at a in a3 r dx3 and potentials is psi r. You can for the fr, gr, and hr, it is this coordinates on the passage transitions. After that, which is the close the boundary which lies on r is infinite, then choose m square is the minus 3. The size of the dimensions of some mass field scalar operator potentials to the masses is 3. The asymptotic of the measurement fields and the mass color are given by is that for the limit r to the of uh, unlimited and r potential Newton is m and limit r is infinite I3 is p. See, we assume the isentropic antidecitor FGR have equal to r square. In the general sense, it will select that lambda is 1 divided by 10 and q is 1. Theory of this characterized by dimensionless parameters taken as that. This show the quantum critical point transitions at the MC is equal to 0.74. So I have the three types of solutions. Namely, the first one, m's bigger than MC. So if the m's bigger than MC is isolated background area. After that, you can see the for m equal MC. It is the critical background area. And the last one, if the m less than MC, it is semi-metal background area. So for background areas full of flow RG, it can only be found numerically and so the fixed point IR different depending on dimensionless parameter M. You see the equations for the depending, and for the beta 1 and beta 2 for the equations, it is functions of parameter. And you see that for the m lambda q, it is this new radial coordinate. So in the conditions for 1, have the value that are near the horizons A3 and will always be 0, and the value of psi is root 3 divided by lambda. It is the position of the gap solutions for the solution m bigger than MC for the number or the isolated background area. After that, at the quantum critical point for the number 2, the theory display anisotropic scaling like the Liftshitz parameter at z and is induced by the axial measuring field source A3 for the equations that you see for the equations for f rho you can get for the exponential 2 divided by z and 1 divided by z. Z have the equal is m squared plus lambda psi squared minus 2q squared divided by 2q squared. If I calculate for the constant, I got this 2.46. Horizon value of the A3 practically is almost always 0, while the value is limited to size 0. And it is the quantum critical point to, or you can see the for back for m equal MC or the critical background area. After that, by reduce the parameter value m become lower than the critical value, we enter the semi-metal basis for the tree. If the base tree, you can have the conclusions for the semi-metal background area for identifications is the m less than MC. Okay, so you can see the equations, two equations, and for the A3 and A1 have the relationships is the horizon value is their A3 is finite and A3 is equal to A1. And you see the for the right equations psi rho can and 1 will disappear for the calculate. After that, I want to solve for the results the computing. The consider anomalous Hall conductivity the, depicted in the left figure. And I got the equations for the translate the figure, sorry, for the sigma h a h e have equal a3 on the origin. After that, I want to show the conductivity saber as the non-localized sequence of parameter for GFG, and with disappears in the topological trivial isolations basis. And interested about the sequence parameter does not obey to the descriptions of the mean field theory, but you can see the equations for that. And you can see the four on the picture on the center, and it is the MC equal about the 0.7 sorry 744. After that, I want to be tell you the theoretical basic on my presentations. It is functions for the Liftshitz legal system, transverses, and the parallel sets with their respective dimensions. If you get D1 and D2 and you want to be plus the variable D1 and D2 or the constanta, it is have equals is D. Uh, I want to be solved what the difference calling is that, and you can be solved see on the prisms, and the finite rotational difference is SOD. If SOD1 times SOD2, it is have the relation for the time instead. So I got the naturally for the shift functions of this the theorize and give it to equations. You can see that for the equations. And I want to be tell about the bond geometry, and the second is the long plates. After that, you see for the dimensions D1 and D2, it is the two rotational invariant spatial planes, and for the beta for dimensionless is the dimensionless normalization constant. So it is the theoretical basics I have to the explain that's for the theoretical basics. It is topological passive transition and like Liftshitz, she function like Liftshitz. After that, I want to result and discussions for my presenters. After that, uh, things to reveal the critical point of function C. Uh, to find the quantum tipping point, we compute C functions the corresponding to the entire surface with the boundary length close enough to extend it all the way into the mass. So practically speaking, the external parameters is M, range of which can cover three different theoretical phases. So like as the before I want to explain, before I explain, I had to tell you about three phase transitions and one back to explain it. The first one is trivial. The trivial is bigger than 0.744, and critical point is equal 0.744, and semi-metal whale less than 0.744. C functions can also be calculated analytically in the conceptual geometry. This type maintains anisotropic along the flow origin. Obtain an independent cut of them, are which as follow the equations, and you can see the from the computing about that from the dimensional C for the function C on the M for the axis X So by extracting the C functions from the entropy of the winding, we get that, and you can get that. The function compared to C minus 1 be single value because that. After that, at the quantum typical point M, the symmetry of the system changes the results in the splitting of the C functions, and it is continuous jump its value into the new constant. It's depending on the corresponding effective dimensions. You see that for the minus. The identity of the effective dimensions of numerical data. We isolated the critical exponent by calculating the derivatives of the logarithmic ratio for G11 divided by the G22. Yes, sorry, G33. I want to be show you about the computing, and I want to be explain the detail. What is this for the black line, red line, and blue line on the figure? For the t is 0 and m is 0, it is the normal value of the C functions. And you can see on the center have the black line. The black line indicated the value of ADS. After that, you can see for the like as this normalizes diagram, it is the have the red color for line, and you see for the blue line is that. And I want to show to you about this picture and feature for the result executions for the computing. For the difference about the critical point on the dimensions for order and difference dimensionless on M and T. After that, I want to show the quartic coupling for lambda, and for m's and lambda have the correlations logarithmic to upper. After that, I had to show to you for the percentage error for a critical point. So for the last one, I want to tell the conclusions for the seminar. The first one, uh, it is a very important. In this work, we have considered the holographic model to showing a topological quantum basis transitions, or the TKFT. The quantum tipping point associated with the transition between the trivial topological insulator and the gapless wave semimetal display the critical anisotropy, such as the Liftshitz point, and the critical scaling incompatible with the standard Landau paradigm. We have shown that the anisotropy of the C functions reaches the universal maximum at the locations of the quantum critical point, and can sense a highly accurate and efficient probe for detecting TKFT. Okay, the result is very successfully. Why? Because uh, in defending the critical point, which is also independent of the nature of the topology. This is the second my conclusions. After that, for the three, uh, given the opportunity known the basic transitions, and will be interesting to investigate device and the finer probes with the server to distinguish topological quantum information from the critical point. Okay, uh, naturally possibly is how to consider what it means by topological entanglement entropy, which has already been discussed in the holographic. In additional, it is very important. Why? Because to understand more deeply beyond the qualitative argument of the calculating for dove. What is the origins of the fundamental shift functions? To pick and whatever from the before picture, or not, it is connected with the feature of the transverse coefficients. Okay, so it is my presentations for today. Thank you for attention for audience. I hope my material on the presentations be have be understand to be shown for the more research knowledge. So thank you.